Jonas, he knows. Thomas, he knows. He knows the one.
This was extremely uncomfortable.
All right, guys. Friday. Remaining 5 minutes of your availability. I assume your weekend will be spent with other things than learning. Well, I hope it will be, but you know, reality. I was a student as well. Two things. Number one, Jonas, you made a tutorial about what actually?
About CMake.
Ah, there you go. Do you want to lose a few words on it? If you can just run over it or just intuitively. It's your contribution, so it's your some. Yeah, that's not what I intended to. I was intended to perhaps have him, say a few words of what it does and what the purpose will be. I can just bring it up. Hang on. There you go.
Yeah. It's a bit.
I will link it to the main page. So it's basically a introduction. Yeah, you probably run over it. Is it like recent CMake or the? Do you consider the legacy functionality?
Yeah.
Okay. So yeah. So the ones of you that were here like probably 3 weeks ago, Jonas gave a bit of a primer on CMake. Learning it bottom up again because our messy CMake lists files, which are at the very core of doing the deployment. And I think this is kind of a response to that one, so in a way of shaping it into a coherent tutorial. So writing a minimal program, how you actually compile it, what it's the operational steps, what are the aspects you consider, dealing with directories, which is kind of a bit annoying, and anything else? Hello. Defining target properties. Yeah, I will invite anyone. I mean, I can only gain at that stage here, so this room is fairly empty. In fact, if even less people come to the sessions, I'll probably suggest you do it in my office, so at least we can annoy someone, meaning my colleagues, and still be comfortable. Yeah, let's hope you stay with me, implicitly or explicitly. So yeah. Anyway, so the idea is basically just to run through with increasing complexity through CMake, right? So and then build from scratch how to link sub-projects, multi-file projects, and all that kind of stuff. The questions of how to introduce headers in addition to the source code files, and linking to system libraries. Yeah, there's some coming soon. So you're still on it?
Yeah.
Okay.
It's gonna evolve. That's why maybe I'm gonna wait. Present, but maybe.
You wanted to wait presenting it. Sorry for that.
Maybe.
Yeah. Okay.
No.
Okay.
Not like that. I would like to. Maybe it's just better to just have it there.
Yeah.
And
cool.
make it evolve through the semester and
generically.
You can have a look.
Yep.
They're interested.
Cool. I will link it under tutorials, so you guys have a CMake attack point as well, right? So particularly for next project and so on, or for the next assignment, then you can use that as a starting point. So thanks in any case, because it's quite nice to have this kind of systematic approach towards CMake and not fall into the pitfalls. Like similar to OpenGL, it also has the issue that there's a lot of legacy information around because it has been a long-lasting project, has been built over time. And so it's easy to get in the wrong direction, even you think on the right track, and you're just hacking around against the wrong CMake version, which kind of doesn't work. So, cool. So that's good. Again, I will link it there.
Please give feedback if what's unclear and what's
issue tracker. I guess right. It's one way.
Post issues.
Post issues.
What do you want to see more of? What do you if you want additional points, I can make. I can expand it.
That's something. I mean, you could. I think you can modify the. Of course, you can modify the wiki. So you probably could even intervene on the wiki itself. I'm not sure if it's like fixing typos and stuff. You probably don't need an issue for that, right?
Yeah.
Because it's all in the versioning anyway, so you can just pull it and see and go back in case somebody deletes something essential. I don't know. You're the owner, so I will not prescribe any means of interaction.
Make pull requests.
Yeah.
Oh, that one. Yep. Cool.
If you're editing the wiki, just append stuff.
Yeah.
Don't delete, but just append expand as much as we want.
Exactly.
And we can merge, sort of merge it.
Yes, yes. Well, you can check this entire wiki out, right? So you can run it locally in principle. It's like Markdown. You need to have some means of rendering it, I guess. But that's it. But it's all there. Cool. Anything else I wanted to say? Yes, something I wanted to say is, first of all, on Monday I won't be here because being Christian's son, but Ahmed and Peter will be there, so you'll be in good hands. And, you know, so that's the incremental next step. The other thing we talk about is that assignment 2, we kind of need to make the specs sharp. We actually have only 2 assignments in this course, which makes it quite simple, right? So we have assignment 1, which is finished, and assignment 2, which is the idea of moving more into 3D, so you guys can actually explore options. And a few things that I want to do is, firstly, to gauge if you have certain. I talked informally with some of you guys, but it's probably a good way of thinking about, okay, what are possible areas you want to explore? We have some ideas we can push you into, but we want to give you a bit of freedom of actually defining your own second assignment. So if you had some aspects that you wish to explore, what would those be? Is there any particular idea? Things like, for example, do you want to write your own game engine, or do you want to deal more with interactivity with devices, or computer vision, or something that goes beyond what we do, or do you want to concentrate on the mechanics of a game, for example, or the aesthetics? I mean, there's different directions you could move in. Yeah.
I would like to look at shaders a bit more.
Yeah. Okay.
Like different kinds of shaders.
So you want to explore the whole stack, if you like, of
maybe
shader types. Cool. So then we need to think about a kind of, and that's where you can come in as well, to think about a project that exploits that, right? So if you, I mean, you guys did everything apart from tessellation, I think, right? So in your project already, you had geometry,
yeah, we had
fragment and vertex.
Full state.
Sorry. Well, you use them. Okay, so let's start somewhere. That's exploiting. I mean, you can always code against the spec in the end. When if you to exploit that, we won't get as far in this course realistically anyway. But I think to use things like this. So it's probably worthwhile thinking about what would you want to model, right? Do you perhaps want to more concentrate on actually modeling some very detailed model as opposed to having game interaction as a basis, right? So that would be one avenue to go down. Other ideas? I'm just collecting right now, pretty much, right? So, and then we can still refine. We'll pitch ideas, that stuff you can do, and I can tell you what the default will be. Surprise, surprise. Any guesses? Yeah, well done. So, of course, with certain requirements, but the idea is the features are roughly the same, right? So the advantage if you fall for this default approach, basically, it means you can capitalize on whatever you did, right? So if you have a solid, setup of your Pac-Man mechanics in the widest sense, then you don't need to deal with that boilerplate stuff anymore. You just can concentrate on the graphics, right? So it takes away a lot of this burden. But on the other hand, we also felt like not everyone wants to develop a game necessarily, for example, right? So but actually just wants to play with graphics, like you guys implied. And that I think we should honor that as well, because fundamentally this course, let's say, it's called graphics, right? Forgot. It's not called games in graphics, right? Or something like this. So it's a bit of we want to give you the freedom to shape that. Especially since this course is kind of the end of graphics as well. I mean, there's this GPU course, but in principle, in third year, you can use OpenGL, but there's no, follow-on course that strictly relies on graphics as such. Yeah. So that's why you need to use all your energy here. Get rid of it, and then be frustrated enough never to touch graphics again, or to specialize in it for your bachelor or brave. But that's obviously up to you. So any other ideas? So we have 2 already. I note them down so we kind of not lose track of them. Shaders was one of them. What was the other thing? The rest was me talking. So any other?
GPU component.
Okay. That's hard to.
Doing physics simulation.
Whoa.
Never mind.
Okay, let's put that down here. Right. So that is the next course that is yet to be designed. The point is, I have nothing against it. The issue is there, and I don't oppose the idea that you independently research the area. Problem is, how do I compare the results in terms of marking, right? So I mean, it's like it will be pretty hard to mark that. So that's the major concern here. Not so much that I would inhibit it. But if you convince me, however, that this makes sense and fits into the pattern of that's roughly equivalent in terms, of functionality that we have learned here, so things like, the transformation elements, lighting, and so on, textures and so on, then I will be perfectly fine. So we will come up with a criteria catalog when you tick the boxes, and then we'll be willing to accept your proposal as well. So it's a matter of framing in the end. Any other ideas, just to flexibility?
I remember that you had an image on the topic of subsurface scattering.
Yeah.
There was like a head with a brain inside and it was glowing or something.
Yeah.
I would like to try to mimic that image through OpenGL by using different shaders.
That's interesting. So it fits into the shaders. So you're really more into graphics, right? In this particular case. So that's like the.
So like the idea is pretty much to mimic an image that already exists. So.
Yeah. Okay. Realistic rendering. Okay. Cool. It's also good. Then I know what direction we could look into as some of the aspects, like for example, looking at transmission of light and refraction and things like that. Yeah.
Maybe game engine.
Game engine is cool. Yeah.
CD generator.
Again, sorry.
World generator.
The world. So
Kind of.
the world generator in what sense?
You make terrains, there's some trees, flowers, and so on and so forth, and you draw them.
And so are you making it, or is the computer making it?
Well, yeah, I see.
Right. Either way, but game engine sounds good.
Yeah.
It's definitely a direction. So, of course, if you write a game engine, you're most likely to end up with some sort of prototype as well, right? For that one. That said, hang on, let me think. Well, if you for the final for the exam to some extent, you probably benefit from having some sort of framework that you designed yourself, ideally, that accommodates all the features that we talked about, right? So it's worthwhile to frame a second assignment towards that as well, right? And the first one could have been that as well, that you already have some, the whole OpenGL boilerplate is settled, you're dealing with textures in a dedicated module, and you're separating the shader management out. You guys had a good example there again on this one. And I probably need to admit that sound is a nice to have feature, but certainly not a requirement at all. But there are certain examples of how you can make your life easier, and even a second assignment maybe worthwhile think about, okay, what did we talk about in lectures, and working towards those ones. But writing a game engine is definitely spot on in that respect, I guess, because that's pretty much the features, right? So game engine also implies interaction, right? So you need to think about keyboard, mouse, perhaps other forms of input. Ahmed has some good ideas on that, so perhaps we can use more advanced input mechanisms as well. Yep.
An object viewer, like the one you
OBJ viewer,
use to show 3D viewer, so you can like peel off, for example, peel off the different layers.
Cool.
Peel off textures, so you only see the mesh dynamically, like during runtime.
Cool.
Swap out the object during runtime, so that like.
Cool. Yep. Oh, that's ambitious though, right? You get that. I mean, it will be straight for the issue usually that you have with this one is scalability, right? So the metric for those ones is how many vertices can you render, right? So where's the limit? 6 million, 10 million.
It's a good way to like test.
To test that.
Test the engine.
So it's like model loading and rendering, right? Real-time rendering. So and then you have the interaction element as well, right? Because you want to navigate around the model. Are we missing anything there? You can introduce lighting as well, right? So by having a light source and then apply this to the object as well.
But it's so I like it because it's all about the rendering. It's not about like any game logic or anything. It's
along the lines of here, right? So we have a cluster of rendering here. That is more like the realism, and this is generally dealing with data format handling, I guess, is also an element there. Cool. Okay, so we have this graphics more centered. This also falls in this category here. I'm not sure if that's a bit odd. Doesn't quite work. So and then shaders, So game engine. So we have two clusters, rendering and the other cluster being probably game engine. Any other ideas of things that we're going to do? Yep.
I'm not sure where to put this, but I've heard about the GPU instancing.
Yeah.
what is that, and will we learn anything about it?
Probably not, but that's wrong. We will talk about it conceptually, but probably won't get to the implementation stage because you will waste enough time on the other stuff we do first. In fact, this would have been the content and would be the content of the successor course, right? So there is a GPU course in third year. Yes, no? Who knows about this? It was generally offered. It's kind of a research style course where you want to, similar to here, that's why we're doing it kind of here, dedicate yourself to a particular topic in the area of GPU processing. And it can be number crunching activities, parallelism, things like that. So graphics is just a lateral aspect there. It's just using the capabilities of the GPU, right? Because it's so incredibly fast, right? Yes, so again, it sits down here in this area there to be defined. I struggle to see that fitting into that assignment right now, admittedly. Yeah, but I appreciate that it's an important topic and it's probably worthwhile exploring. And I will carry that forward as well into the discussions because you guys know that Simon's leaving, right?
Yeah.
Cool. So there will be probably a bit of shifts also programmatically, right? So that could imply that we're opening up initiatives towards doing the more raw programming, for example, less game focused, if you like, right? If you don't want to, and more focusing on those aspects. So there may be flexibility there in shaping it around you in this case. So as opposed to strictly looking at games. So, but this course is on the books, so it could possibly be revived. But again, let's make that future music, please, for my sake, actually. So, any other ideas? Back roll there. Now's your time. You can give input into the course, but also into your own assignment. Yes. Where can you do that usually? Ah, there you go.
More about like making a framework, so how to set it up so that it sort of uses the pipeline in OpenGL in your code, so that you can see clearly what is OpenGL and what is not, and how it works.
Yeah.
Something I would like to have in focus whenever, like, if game engine is one of the alternatives on the assignment, I would like.
Yeah.
I would like to learn more about actual scalability and modular. I mean, modular ability, but like just compatibility between different sections, so we don't end up with problems that we have, other problems where you just can't solve something because there's too many components.
So it's more like
how do you make many pieces fit together in a big project?
Okay.
Because that's what the game engine task will be, I imagine.
Yeah, to some extent. Okay. Patterns. Yeah, okay.
Design patterns.
That's a good idea. So we could think about using design patterns in the context of games or generally?
In the context of games.
Good.
So you could base it on the book, the game program patterns.
Exactly. That would be the natural link there. I think that's a good idea. The one that Per Morton pointed us to, right? So you guys saw that, if you saw that stream. Yeah, architecture, patterns, and things like that. Yeah, cool. Yeah, that's an important aspect as well. Kind of goes with this ish, kind of along those lines. Yeah. Okay, good point. Another aspect? Yes, no, perhaps? No substantial input. Okay, so we have a rough idea here. So if
VR.
What else? VR. Okay, open down.
AR.
I think it's realistic for your bachelor project to think about this. Cool, actually, good idea. But I think there's too much boilerplate on that one to get to that one effectively, right? So meaning you in this course you could prepare, for example, you position yourself in space, right, and do the navigation bit. But if you include VR, the load will be on thinking about tracking, positioning, and things like that, right? So, and this will be just a mechanical translation into what you would do in this course anyway. If you get the concepts right, then it's just an extension to the course, but not necessarily core content, if you know what I mean. I think it would obscure the focus of the course towards a new physical problem, in fact. Yeah. So,
I was just thinking about the rendering of VR. Like you just render two views, but you need the tracking
Right.
If you only have the rendering and you just have a fixed,
Exactly.
it's really painful, I guess.
Yeah.
Just look through the glasses.
Exactly. Yeah.
But the rendering is very independent from. You can make the game normally and just add on the rendering at the end of the pipeline.
Yeah.
Like it's the I think this is the last step in the pipeline, like on the shader. So it would just be another shader.
Yeah. Yeah, it would be one angle. The only concern is simply that we wouldn't waste too much time getting that whole thing going and setting it up. But I think that's something to carry on into your bachelor, Oka, because there's team working on you. So you guys know what the others are working on, right? In bachelor?
Some of them.
Some of them,
Yeah.
right? There's one of the guys that do the racing game, right? So
Yeah.
some of you may have seen it. It's actually pretty cool. So that's definitely something you want to think about. Perhaps interact with those guys. And but they're doing it in Unity.
The VR room.
Yes, in VR room, but they're using Unity, right, for modeling.
Yeah.
Yeah, for sure.
So you don't do it from scratch, really.
For modeling,
For designing. Yeah.
Yeah, they're not focusing on by
Not modeling.
building it from scratch. They're
They're
They're designing it using Unity for everything.
using assets.
They're using Unreal.
That's right. Yeah, of course. Yeah.
Oh,
If I talk modeling, I come from a different tradition that says you also model architectures, not only the 3D models. That's my mistake. Sorry. I
Yeah,
think
I
that's a
would
modeling
agree.
problem. Right?
I would agree. Yeah, and non-context.
I know. That's my.
Yeah, context model is really.
I mean, I know Unity, we've edited it.
I don't know.
That's fine.
3D modeling.
No, I literally had a talk on modeling in a different context this morning. That's why it's on me. So I agree. So yeah, good. So, but something to look at, I guess, to talk with them and perhaps immerse yourself. But I think this can be well done in third year anyway when you look more into using Unity. I think try to exploit this course to really get into OpenGL if you want to, because the threshold of getting in is relatively high. But once you're in, you can play around quite a bit and exploit it, and then you at least know the feature set. So, and if you just feel like, okay, the future you want to exploit one element of OpenGL that is not quite well accessible, for example, using Unity, it's very tedious to add that in, right? So, because then you have like two systems you need to architecturally combine, so I would abstain from it from now. But bear that in mind for the future interaction. I'm not sure though, is there a native framework that does VR only using OpenGL for game development? I don't know. It would be something to explore. I'm sure there's something, but the question is how far that goes. Anyway, so I think we have a good overview. I see two patterns here. One pattern I see is clearly on the rendering graphics side. The other pattern is on the game architectural game development side of things, right? So both have their merits. And bear this architectural point in mind for whatever you do. So you want to have reusable structures that may help you in your exam. Because for the exam, you can bring your own code, right? So we need to talk about whether and how far external libraries are permissible or which external libraries are permissible, but you will be able to develop your own framework in advance. So you have kind of a head start as well in that respect. Cool. Right, so thoughts, questions? Yep, please.
When did it start? And when do we have to...
Yeah, so I will set the deadline for I still haven't spelled out the specification quite cleanly yet because I wanted to do that fact-finding mission first. But the end will be about end of, don't get this wrong, end of April.
Okay,
so you have
we are starting after the holidays?
No, you start before the holidays. I hope by mid of next week or end of next week, Monday I'm not here, but by end of next week I have the specs out. Yeah. So you guys can actually go and hack. I mean, intuitively, if you feel like Pac-Man 3D, you kind of know the specs-ish, but so you could start exploring if you like, but the specs will be out by then, so you will have then roughly 6 weeks to do it. Kind of could work, right? So, and yeah.
So is this a group assignment again? Or
Yep. So in fact, you can. It's up to you. You can remingle, but you can capitalize on your, social capital, if you like. If you develop the links and your collaboration strategies and use the same group setting again, of course. Yeah. In fact, I would strictly encourage it. Because the learning, I think, is so much easier. Also, task distribution is so much easier if you do it. If you disagree and want to do it on your own, knock yourself out. I mean, but it's probably not a good idea. There's some. Are you thinking about doing it alone now? So, it's obviously more work if you do it on your own, right? Because the benchmark, the metrics will be kind of the same. but no, stick to groups would be my default suggestion. Rather extend more features than you know, starting it all from scratch on your own, I guess.
Well, I mean,
Other thoughts?
start from scratch because
No?
we use
More details on that next week. Yes, cool. So what did we do? Ah, that's what we did. So last session, we got some overview of the OBJ format, right? So, and I didn't quite wrap that up. I still wanted to. So that should be reasonably clear. What are the elements involved? How do we do some rendering? You know, sorry. How do we do model loading? Quite primitively, in fact, right? So what are the different features that are involved? And the idea is there that the OBJ framework, and that would be interesting for you if you really want to pull that off, is that the complexity is actually a bit like that, right? So as soon as you get into the more advanced features, like grouping and merging elements using libraries, it actually becomes a bit more complex. There you go.
Yeah, but if I just use the library loader.
Okay, so you just want to use the library loader?
If I do that, I save like maybe
Yep.
3 weeks.
Oh,
It's 5 weeks.
definitely. You solve most of the issues because you get a complete graph, and your role will just be to render it. In fact, if you do it clever, it could be relatively straightforward because you can use a scene graph and then plot that against the, use that to represent it in your window, basically. It could make it relatively painless, I agree. So, of course. But again, the format can be quite, the starting point is super straightforward and simple and maps well into what we talked about. But in the advanced level, it's getting a bit more involved. So, but I think you should have some understanding at this stage. That's an example I showed, the algorithm. So I'm not going over that one again. But there's some other formats, talked about material as well. There's some other formats that are worthwhile exploring. So probably the most well-known open source loaders, at least, are a tiny OBJ loader, which is slightly more limited. So it's not as flexible in terms of formats. ASM, the one we used on Monday, or that you will continue using, I think, next week as well. So Ahmed still needs to define that. Will also support a large number of different input formats, right? So you can actually get your own models from elsewhere and actually just load them and use them. So it makes it actually quite flexible. And it's good to know because it's a kind of a standard tool, has been around for ages, but has been widely accepted, and also has a large number of language bindings. So if you don't, interact, let's say, with it from C++, there's other options to do that as well. But the more simpler one, Tiny Object Loader, is strictly C++ focused. And really just focus on speed. That's the major focus. And the objects are simply, the formats are only OBJ, right? No other format is permissible in that particular context. So which other formats do you know? Or did you use? Because some, obviously you are acquainted with the idea of modeling.
So I was wondering, like, MTL, is that another one, or is that something completely different? Because it seems like that has to do with shaders and with representing the object rather than parentheses.
Yeah, cool. So the MTL is basically a companion format to OBJ. So it's the, I'm not sure what to talk about it. That's the material modeling format, the material representation format.
Okay, so when you say OBJ, then you mean with MTL?
Yeah, it implies MTL. So that's an OBJ file again, similar to what I showed last time. You see here at the beginning, it says MTL lib, right? So, and that's the material library it imports. And that requires the MTL specification as part of it. So it kind of hooks into the OBJ format. And then you here's then, that's basically just declaring that you use it, and here's the actual use reference here to a texture, for example, right? How to access the internals. There was some comment.
And it requires that the MTL is in the same folder.
Yeah, okay.
Does it?
Yeah.
That's the question.
I think that's, I haven't tried it, but I suspect that's convention. You can, I don't know. You would keep them together anyway, right?
Yeah,
so because they're
expect them to be in the same folder.
Yeah. So, but most renders are built in a way though that they only require the OBJ format strictly, so they treat the MTL as optional. Meaning, if they don't find the material file, they just don't render the material properties, right? So, like lighting, reflection properties, and things like that. But they will still render the object. For example, the Open3D modeling tool that I showed last time it actually didn't consider the material files, for example. Probably for performance reasons, but I'm not sure why.
Are the textures like kept in the
Yep.
material file?
That is exactly right, yes.
All right.
The material is mapped, here it goes. So that's the components. I may have forgotten. Yeah, I forgot to talk about it last time, possibly. So it includes aspects of lighting, right? So all the lighting components. So how does a particular vertex behave in terms of lighting, reflection, diffusion, specular lighting, the focus of that. Transmission, we didn't talk about this. We had different illumination profiles it interacts with, but it also contains textures. So the link to textures, which are then also in the same directory co-located with the material library, at least for what I've seen. Yeah.
If you look at Lab 7, you can get a good example of how all the files
Cool. Yeah.
are on the nanosuit.
Shall I just bring it up? Hang on. In fact, I'll just look into the repository directly. It's probably easier. Then you see what I see. It's in resources. Yep. So those are the. There you go. So right, the nanosuit is that's right. That's a good idea. So here you see that's the MTL file. So all that one, I'm not sure if you can read it, but it sits in resources under Lab 7, and this is the MTL file. Now comes my skill set in terms of zooming again. There you go. We get somewhere. And so here's the material specification for this nanosuit that you kind of played around with, right? So we have new material with some sort of identifier, and then the characteristics. So here it's about reflective components, illumination models, but also the associated textures that are, that come with the material. So bump mapping, so the variation in lighting across different pixels, and the rest is probably reflection. I need to look it up again. I don't know it by heart right now. But the idea is basically to separate the geometry of the model from the presentation. It's a bit like we know it from web technologies as well, right? So that we separate structure from presentation in the widest sense. And that's quite similar here, right? So that we have the geometric primitives and the objects and groups of them. And then on top, we just code it with, with skin it, with textures, if you like, and other material properties. And they're specified basically together, but consider it as a companion specification of the OBJ format for now. And that's basically it. But yeah, is there anything else we exploit? No, it's quite straightforward, right? So, and then just basically say, okay, which group of vertices, if we go back to the nanosuit OBJ, where you go? There you go. Oops, yeah, bad luck. So it's a bit large. Hang on.
You can load it anyway, it's us.
Yeah.
So
Maybe you can view it if you press edit.
Yeah, that's right. That maybe you're right. Thank you. Good idea. So yeah, there you go. Thank you. So yeah, basically that's the. Hope it's legible somewhat.
It's 50,000 lines.
So it's only 50,000 lines. That's quite handy. So again, reference to the material, and then it will group. So you have an object visor, right? So a visor, sorry. And those are the vertices associated with this. Then there's probably texture mapping, and then the normals eventually coming up, and then the faces, meaning to bind all the individual vertices together. And here's then the specification. How should it look like? Well, use the material glass specification, right? The visor should have the glass characteristics, including illumination, reflection, lighting, and whatever else. So that applies for all subsequent face specifications until, yeah. So let's see. So we're all tied up until we have a new object that resets basically all those settings again, and then we start from scratch. We specify the vertices associated with an object, the vertex texture mapping, right? So how textures fit into objects, the normals, meaning the surfaces, surface direction, and then the faces again for legs. Possibly, wow, they're complex, aren't they? Right, so a few thousand lines later, you probably see something like vertex normals and so on. So the pattern is always the same. You have different objects with different geometry, and then you attach some material to it. And the material specification, again, is in the other file. Right? So, and textures are also specified in the material specification. Okay? Yeah? Too vague? Questions? Thoughts? I put links to the specs. The specs are horribly... Well, they're not too bad, I guess. The ones for OBJ are slightly worse than the ones for material, but they're all there, but they're a bit dusty, I guess, in the sense that they have been around for quite some time. But of course, this is an advantages as well, because the format is very stable, so that's the key idea. And good for exchange. Okay, yeah. Other questions regarding OBJ? I mean, we should do that now. It's a good idea, in fact. Yep.
Is there any relation between the material and the shader that is supposed to use the material? Or like getting all the textures from the material into the shader?
Directly into the shader.
Because you would do the bump mapping in the shader, for example.
Yeah, but we need to load it via CPU first and bind it to input variables in the shader. Otherwise, there's no way you can do it. So, or we're using uniforms if you have global cases. You have a comment?
I imagine you would use the same shader for like all OBJ files.
Yeah.
Like just one OBJ shader. So.
Yeah. So. Yeah.
Because it's the same.
The format is uniform. So
in.
exactly. So that's unproblematic as such. I'm just thinking about a case where it makes sense to differentiate, let's say, between an input variable and a global variable when you use material. Meaning, does it ever make sense, for example, to use a global uniform in a shader and link it to a particular material? I'm just reflecting. I'm not sure. Probably doesn't, right? Anyway, but no, fundamentally no. You load it using ASM and the like, and then you map it against OpenGL. And that is, because the format is well specified, it's relatively straightforward doing the mapping. You just need to, obviously adjust some format specifics. But the interaction doesn't change, so if you go via C++. Okay, other formats that you guys dealt with? Should I give you a break first, perhaps? No. No? No is consensus? No break today? Good. Well, anyway, one format, then we do a bit of a break, and then I have some other, the final format I want to present. So the other one, which is from Autodesk, is used in Autodesk 3D Max, so it has grown over different iterations, and it's kind of a bit the opposite of what OBJ is in a sense, because OBJ was written for a advanced rendering tool that was composed of different components, because it was really written in the 80s, quite earliest time, and was used. You couldn't just do everything in one tool as you could do nowadays. So the focus there was about exchangeability between the tools, right? So you can actually write a model in one tool and actually export it into a different one and use it there. In Autodesk, the perspective was different. It's more about efficiency of the actual format, but also doing everything ideally in one tool. So they had a rather strict specification that is completely in a binary format. So it's not, it's in principle proprietary, even though it can be read based on the specification by ASIM and the like. But it has certain limitations. For example, it has a fixed hierarchical organization of certain elements. So in OBJ, it was a bit more loosely coupled. You model your objects yourself and associate the different vertices and so on. Here it's more hierarchically pre-specified what the structure looks like. So here's an example, or the structure example, that you have some sort of root node somewhere there. You indicate the version, so you can actually support multiple versions. And then you have an object blocks, triangle meshes, vertices. They're still being, the structure is really well specified, or clearly specified in terms of order, and separated by object specifications, light, a camera, and then the material specification, which is also part of the object format. So, but everything is, yeah, in explicit order, and you have little flexibility in modifying it yourself. In OBJ, you can write your own exporter that is optimized against what you want to do, because the semantics are reasonably loosely defined in OBJ. Or no, that's wrong. The semantics are well defined, but the format is flexible in terms of ordering. Certain limitations. It doesn't really support anything else but triangles, so OBJ has grown to support other shapes as well, apart from line points. What was the other one? I think quads as well, and how do they call it? Surfaces, right. So basically that's their equivalent to a polygon, that you basically have an arbitrary number of vertex specifications that, you know, shape a polygon. But here you, internally, everything is represented in some sort of triangle fashion. And there are specification limitations such as that it's only able to store 65,000 meshes, vertices per mesh, so there can be a limitation or not. It doesn't have directional light built in. That said, we don't have that either in OBJ, right? So lighting is not considered. We have reflection, but not the lighting specifically. Please.
When you say max 65,000 per mesh,
yeah,
that doesn't mean per object, right? That does, because an object can consist of
multiple meshes.
For example, the bicer can only be 65,000
Yeah.
versus
Yeah.
the lengths can only be 65
Yeah.
versus the total can be much more.
Yeah, yeah, yeah.
That's the case for several engines as well, with a max cap of per mesh.
Right. Okay.
So in Unity, for example.
I see. Okay. Yep.
So it looks like a mesh is one material and
Combined on the geometry.
geometry.
So yeah.
And then when you change to another material,
Then you have a new mesh. So yeah.
I'm just trying
To get that right, right?
get.
Yeah, probably you need to do a summary on terminology. That's right. Yeah, good point. Yeah. So those are some aspects of that format. So point is, it's really hard to read it on your own. If you want to write your own loader for that one, it's a lot more effortful and a lot less flexible. For example, you kind of can extend the OBJ format with some proprietary stuff if you want, right? So you can encode additional properties if you need to, or limitations are actually literally only not so much defined by the format, but only by the engine, by the loader it uses, right? So what performance can you accommodate with your loader? So it's a bit more flexible there, so it's quite good in that respect. We look at some more the feature differentiation a bit later, but I want to put out this format here as well because it's quite relevant in the industry. It's kind of the industry standard for commercial applications and exchange of models as one of it. Before I do the final format that I want to talk about, I'll probably give you 5 minutes break. Yes? No? Else I talk all the time.
Yeah.
And you sleep all the time.
Let's go get a ball.
All right. Right. You want to. It's not good in the sense of your cost minimization strategy, right? Because the okay, economic disaster. So.
It's fine.